So, as the name indicates, trigonometry is a study of triangles. There is some tri, so tri is always 3. So, it is a study of triangles. So, the first question that comes to our mind, why should we study triangles? Why not quadrilateral, or why not pentagon, hexagon? There are so many polygons, right? Why are we studying trigonometry for 1.5 course, or maybe it starts from 9th and goes till engineering? Why is that triangle is so important? So it turns out that
it's a basic polygon.
One thing is it's basic polygon because it's the smallest polygon that we can get. All others have more than 3 sides or 3 vertices and so on. And one more thing is, suppose you take any other polygon, you can divide it into triangles, right? So suppose you know the property of every triangle, you can add up all these properties and get the property of the whole polygon, right? So it's enough if you know the properties of triangles. So once we know the properties of triangle, we will know the properties of any polygon. We can divide it into different number of triangles and get the properties, right? So triangle is important. So let's study triangles. Okay. So let's write down what are all the properties that we know about triangles. Okay. So suppose there is a triangle ABC. What are the properties that we know? It has, first basics, it has 3 sides and 3 angles. Next property, sum of angles is, right, so I'll just write it as A, B, C is 180 degree. You know these notations, right? Angles. Okay, next.
Sum of 2 sides of an angle is more than the third side.
Right, so if we add 2 sides, it will be greater than the third side. Everyone knows it, right?
Yes, sir.
Okay, so yeah. Sum of any 2 sides is greater than third side. What happens if it is equal to?
You can't form a triangle.
What will it form? It forms a straight line. Suppose you have this. Sum of AB plus BC gives AC, right? Yeah. So if it becomes equal, it becomes a straight line. If it is less, it is not possible to construct such thing. And if it is greater, it forms a triangle. Okay. And what else we know about triangles?
The centroid will be located in the ratio of 3:1.
Okay. So let's not go into much of that. Okay. Let's list out some basic properties that we need. Okay. It's also a property. I'm not telling that it's not, but yeah, let's first finish all the basics. Okay.
Triangle can have only one right angle.
Right. So only one angle can be greater than or equal to 90 degree, right? If we have 2 angles, their sum itself becomes 180, so other angle cannot exist at all, right? So it can have only one angle which is greater than or equal to 180 degree.
Only one angle can be obtuse too.
Yeah, so greater than or equal to. Okay.
The side opposite to the largest angle is the longest.
Okay, fine. The angle opposite to largest side is the largest angle, right? Or in other words, if we have a triangle like this, suppose we know that AB is greater than AC, suppose we know for sure, right? So the angle opposite to AB is C, right? So angle C, angle opposite to AC is B, right? So C will be greater than B here in this triangle ABC. If this happens, then this happens, right? So if we know 2 sides, one is greater than the other, we can tell about their opposite angles. In the same way, if we know about 2 angles, we can tell about their opposite sides. If I know for sure that angle B is greater than angle A, then I am sure that AC is greater than BC. Okay, fine. So now, for trigonometry, we even forget triangles and concentrate on right angle triangles. Okay, so before going to why we do that, yeah, maybe let's first discuss why not any triangle and why only right angle triangle. So suppose I have any triangle, what I can do is,
It can be divided into two, right?
right, I can take one vertex,
Medium.
I can drop a perpendicular, so now it becomes two right angle triangles, right? So if I know the properties of right angle triangles, it's enough. I need not know the properties of whole triangles. I can add up the properties of this triangle and this triangle so that I'll get the property of the full triangle, right? So first we thought triangles were special. We got to know why. And now we leave all the triangles and we concentrate only on right angle triangles, okay? And even if it was a triangle like this, even then we could have done this. We could have dropped a perpendicular. Yeah, we can draw it inside, but even if we draw it outside, it will be the property of this bigger triangle minus the property of this triangle, right? So even this way can be done. Okay? Yeah, so now we concentrate only on right angle triangles. Okay. So now let's write the properties of right angle triangles here. So the first property is right angle triangle is
One angle is 90.
one angle is 90 degree. So and that is the reason it is called as right angle triangle.
Hypotenuse is the largest side.
There is something called as hypotenuse, which is actually the side opposite to 90 degree. So let's write a triangle first, which is a right angle triangle. What's it? Side opposite to 90 degree is called hypotenuse. And we have already seen that there can be only one hypotenuse. Why? Because there can be only 190 degree. Alright. Okay, so we know.
The two angles in 90 degree.
Yeah, so it's too basic to write. We know something called as Pythagoras theorem, right? What does it say? Okay. So that is if the triangle is named ABC and the hypotenuse is AB. In general, how can we say the square on the hypotenuse in any right angle triangle, the square on the hypotenuse is equal to sum of the squares of the other two sides. So in this triangle ABC, Pythagoras theorem says AC square is equal to AB square plus BC square, right? So all these things we know. So you know the proof of this Pythagoras theorem, you know. Fine. So you know why the angle should be equal to 180 degree?
Yes.
Okay. I think you saw in the last class by that construction. Fine. Okay. Yeah. So all these things we know. Can we start with the new things that we don't know?
Yes.
Okay. So suppose I have a right angle. So now on for all the discussions, not only here, even in later when you go to your college, engineering or whatever, you will study only about right angle triangles. The reason is any triangle can be decomposed into or constructed into two right angle triangles and you can do whatever you want. Okay, so now suppose we have a triangle. I know there will right angle triangle. In any case, if I tell right triangle, it's always right angle. Otherwise, I'll tell you if it is some other triangle. Okay, so now suppose I have a right angle triangle. I am sure that one angle is 90 degree. So I'll have one hypotenuse for sure, right? So this is hypotenuse and this can never change. it will be always hypotenuse. Now, suppose I fix this angle, then this side is adjacent to this angle, right? And this side is opposite to this angle, right? Suppose I fix this angle, this side is adjacent and this side is the opposite, because hypotenuse is always fixed. For this angle, this cannot be the adjacent because this is always the hypotenuse. So we call this adjacent, and this is always the opposite for this. So in any right angle triangle, if I mark one angle, then its adjacent side becomes fixed and its opposite side becomes fixed, right? Because we can know how to mark it. So let's fix some angle. Let's say this angle. So let's call it some alpha degrees is here. Okay. So now, if this is alpha, so yeah, maybe let's take some ratios. Okay. So I take the ratio of BC by AC. Okay. I don't have any other work. I just took its measurement and I just took this measurement and I just took the ratio. Okay. So I'll call this, say, sine of alpha. Okay. I just call it by a name. If I am telling alpha, with respect to alpha, what is this? Sorry, I'll call this cos alpha. Okay. So what is this? This is adjacent, right? So I can write this as adjacent divided by hypotenuse, right? Because BC was adjacent to it, alpha, and AC was always the hypotenuse. Okay. I can also take this ratio, right? AB by AC. Right. So I'll take AB by AC. I'll call that to be sine alpha. So with respect to alpha, what is AB? It is opposite, right? Okay. So opposite by AC is always the hypotenuse. Okay. I can also take AB by AC, BC, right? I mean, there is nobody stopping me to take ratios. So AB by AC. This will be, sorry, that is all. So this one I'll call it as tan alpha. AB is what? Opposite, right? So opposite by BC is what? Adjacent. Okay. So once I have this, I can take the reciprocals also, right? Instead of AB by AC, I could have took AC by BC. That would be hypotenuse by adjacent. So if I take hypotenuse by adjacent, I'll call it as, say, cosecant alpha, and for sorry, right, you are smarter than me. Okay, so sine alpha is opposite by hypotenuse, and if I take its reciprocal, it becomes hypotenuse by opposite. Let's call it as cosecant alpha. We are giving some names, that's all. Those who are seeing it for the first time, we are just taking some ratios and giving some names. Let's see after some time what's the use of this, why are we defining all these and all. Okay. For now, there is a triangle and there are sides and there is an angle. Once I fix an angle, I will know what is an opposite side and what is an adjacent side and what is the hypotenuse. Once I know the three things, I can always take these ratios, right? So I am taking the ratios and naming them, that's all. Okay. So these are all the definitions. The definition of cos of any angle is construct a triangle of that angle, mark that angle. Once you mark that angle, you will get its opposite, adjacent and hypotenuse. Take the adjacent divided by hypotenuse. Whatever ratio you get is the cos of that angle. That's all. Okay. So now, can you construct your own triangle and tell me what is the cos of 30 degree? How would you do it? You would start by constructing a right angle triangle. You would make one angle to be 30 degree. if this is 30, this would be 90, you would get a triangle like this, you would construct it, then you would measure this side and this side, there would be some measurements, and then whatever ratio I would ask, you would look at that. If I had said tan 60 degree, you would know 60 degree is here, tan is opposite by adjacent. For 60 degree, which is the opposite, this one, you take this measurement. What is adjacent? This. You take this measurement, you divide this by this, and you tell me whatever the answer is, right? That is all we have done till now. Okay, so far clear? Okay, so one more is there, so that would be its reciprocal is adjacent by opposite, that we call it as cot alpha. Now, so those who already know trigonometry, please don't answer. So suppose I fix this an angle beta, so those who are seeing it for the first time, can you tell what cosecant beta is? See the definition, mark the adjacent, opposite and hypotenuse for beta and tell me. So for beta, which will be the adjacent?
AB. Oh, AB.
This will be the adjacent, right?
Yes.
Adjacent of beta, and this will be the opposite of beta, and this, because this represents hypotenuse always. So what would be cosecant beta?
AC by AB. AC by BC opposite. AC by BC.
Okay, so for cosecant beta is hypotenuse by opposite. What's hypotenuse? AC. What's opposite? BC. So cosecant beta is always hypotenuse by opposite. I mean, that you need to remember. You will get used to it once you start working with it. So for now, I'll write those definitions in the corner, and for all the discussions, if you know it or if you have already seen it, it's okay. But once I say sine of alpha or cos of alpha, if you don't know it, just see the board on that side. So let's write it down. Okay, so for any alpha, sine of alpha is opposite by hypotenuse. Cos alpha is adjacent by hypotenuse. Tan alpha is opposite by adjacent. Its reciprocal. Cosecant. So these are the only 6 ratios that we can take, right? We cannot take many other ratios. So if you know this, this is something like permutation taking 2 at a time. We already had this combinatrix class, right? So we are taking 2 at a time, and we can order it in any way. So there are 3 things, and we have to order 2 taking 2 at a time. It will be 3p2, 3. So it's 6. We cannot get more than 6. Okay. So now you should get a doubt. So the doubt is as follows. Suppose I create a triangle, right angle triangle with alpha here, one triangle, let's call it ABC. Okay. Now I create another triangle with the same angle. With the same angle, I can create a larger triangle, smaller triangle, any triangle, right? So let's call this XYZ. Okay. So in this case, what would be sine alpha? Opposite by hypotenuse, that is AB by AC. Here sine alpha is XY by XZ. Okay. So now we said if you take this triangle, it's that. If we take this triangle, it's that. So it's changing, right? But if you right. So if you observe, there is a 90 degree here. These two angles are same. Therefore, this angle has to be same as this angle. These two triangles are similar. What do we know about the properties of similar triangles? Right. So the ratio of their corresponding sides are equal. So now what are the corresponding sides of these two? Angle opposite to 90 is AC here, right? So it's here XY. So let's write it down. Angle opposite to 90 degrees AC, here it is XZ, that is equal to angle opposite to alpha, there is side opposite to alpha is AB, and the side opposite to alpha here is XY. Side opposite to the remaining angle is BC there, and here it is YZ. So we know this, right? Because those two triangles are similar, therefore the corresponding sides are equal. Now we know this. Suppose I take this here and this here, I take only these two and cross multiply. XY goes to numerator and AC comes to denominator. So what happens? AB by AC becomes equal to XY by, so what does it, XY by XZ. What does it tell? Whatever the size of triangle doesn't matter. Once we have a triangle and we take the ratio, it becomes same, because we just proved that if we take this also we get a value, if we take this we get this value, but we know that these two values are same. So this ratio, what the sine, cos, tan, whatever we take, is not dependent on the size of the triangle. It is dependent only on the angle. Okay? So it doesn't matter if I take a small triangle, big triangle, large triangle. Okay? So it only depends on the angle. So we define it only with respect to angle. We didn't mention what's the size of the triangle anywhere, right? We just said take an angle, construct any triangle that you want, any right angle triangle that you want, mark these and you get these ratios. Now you know why? This is because you take any size triangle, the ratio always remains the same. Okay? So far clear? So this is called as this doesn't change with respect to size of the triangle, right? So whatever is the size of the triangle, these ratios remain same. So such properties are called as invariant properties. So any property that doesn't change with respect to some changing things is called as invariant. It doesn't vary, so it is invariant. So what can we say? All these 6 are called as trigonometric ratios. So trigonometric ratios are invariant with respect to the size of the triangles. It is dependent only on the angle but not on the size of the triangle. Okay? Okay, so now let's construct some special triangles and then try to see what happens. Okay, so now let's take an equilateral triangle. All these three will be 60 degree, right? Let's take an equilateral triangle. All the sides will be same and all the angles will be 60 degrees. Let's drop a perpendicular. This we haven't changed at all. This becomes how much? 30 degree, because this is equilateral. If we drop a median, it bisects the angle, right? So let's enlarge this part of the triangle. Okay, initially let the sides be 2 centimeters each. Okay, the whole thing is 2 centimeters. Let's enlarge only one of these halves. So this is A, D, C. The angle we have here is 60 degree. The angle we have here is 30 degree. What can we tell about the sides? This is always 2, right? We haven't. This is 1. What would be this? So we don't know this by this at all. So let's see only this and apply Pythagoras theorem. What happens? This side is AD square should be equal to AC square minus DC square, right?
4 minus 1.
AC square minus DC square. This is by Pythagoras theorem. Let's substitute. What is AC?
2.
AC is 2, we know. So AC square would be 4. What is DC?
1.
DC is 1. So 1 minus 1 is, 4 minus 1 is 3. So we want AD. We take square root. So it becomes square root of 3. Right? So now we know this is a triangle. Suppose we construct a triangle like this. We can take the ratios now, right? We have a triangle and we have all these 30, 60, 90 and etc. So now once we have a right angle triangle, we can fix one angle, we can mark its opposite adjacent and we can take the ratios, right? So let's do that. Now let's fix 30 degree. So for 30 degree, what is the value of opposite side? It's DC, right? For 30, if you fix 30, opposite is DC. So what would be the value of sin 30? See there, sin 30 is opposite by hypotenuse. What is the opposite? DC. What is the adjacent? Sorry, what is the hypotenuse? AC. So what will be its value? 1 by 2. So what does it mean? Whenever I construct any sized triangle of 30 degree, I take the opposite and I take the adjacent. If I take the ratio, it always gives me half. It doesn't depend on the side. If I had taken a bigger triangle and done the same thing, I would have got some ratio, and if I simplified that, I would have got half. Okay, fine. So once I have sine of any angle, cos of any angle, cos of the same angle is very easy to find, right? Because it's just the reciprocal. Sorry, cosecant is very easy to find, right? Because it's just the reciprocal. So once I have sine 30 is half, what will be cosecant 30? 2. It's just its reciprocal. Okay, fine. Let's find what cos 30 is. What is cos 30? Adjacent by
AD by AC.
Right.
Root 3 by 2.
AD by AC, which is
Root 3 by 2.
root 3 by 2. Okay. So yeah, so once you know cos 30, what will be the value of secant 30? 2 by root 3, right? Fantastic. So now let's do tan 30. What is tan 30?
1 by
1 by 2.
Opposite by adjacent, right? What is opposite? DC by AD. So this will be 1 by root 3. So what would be cot 30?
root 3 by 1.
Root 3 by 1, that is just root 3. Okay. So all these 3 clear? Fine. So with the same triangle, can you find out sin 60, cos 60 and tan 60?
Yes, sir.
Can you do it right now? I'll give you 2 minutes. Okay. Those who already know it, keep it with you, and those who are seeing trigonometry for the first time, do it in 2 minutes. So, few of you came late. You know trigonometry? You have seen? No, you hadn't. Okay. So you understood anything? You didn't understand.
No, I understood.
Yeah. No, but they came late. Okay. So. Okay. So let's write down that whatever we have seen. Maybe after the class you can ask your friends. Okay. Fine. So we have this sine, cos and tan. I'll not write the other 3 because once we know these values, the other values will be reciprocal, right? So for 30 we already found out what was it. Sin 30 is half, cos 30 is
Root 3 by 2.
root 3 by 2 and tan 30 is 1 by root 3. Just now we found out for 60 degree. What's the value for 60 degree?
Root 3 by 2.
Root 3 by 2. What is cos 60?
1 by 2.
What's tan?
Root 3 by
Root 3. Okay. Is it fine? Okay. Now let's construct another triangle, which is a bit special, which is right angled isosceles triangle. Okay. Okay. So this is 90, we know. These two sides are equal, therefore their angles opposite to them have to be equal, right? So both have to be 45 degree. Let's construct with this with hypotenuse value say 2. Okay. So now what will be the value of AB?
Root 2 and root 2.
Root 2 and root 2. So why? Let's just find out. It's because we don't know this. Let's apply Pythagoras theorem. What we know is both their values are equal. So let them be x. So we know that x square plus x square should be equal to 4, right? 2 square. X square plus x square is 4. So 2x square is 4. X square is 2. X is root 2, right? So both the sides are actually root 2. So now we have found out this. From this, can you find out sin 45, cos 45 and tan 45? We have a triangle, we have a 90 degree, both are 45. So fix one of them and find out all the three ratios. Yeah.
You can't have length as minus root 2. Negative.
So anybody who didn't understand his doubt? Okay, so x square is 2, right? So x can have two values. One is plus 2 and minus 2. Why did we neglect minus 2? Because this is a length that we are finding out, and length cannot be minus. Right. Okay. So if it's over, let's write it down. So for 45, what was the sine value? Sine was just root 2 by 2, right? Root 2 cancels and what remains is 1 by root 2. What will be cos?
1 by root 2.
Again it's root 2 by 2. Root 2 gets cancelled and we get 1 by root 2. What will be tan? 1, because root 2 by root 2 it cancels out and we get 1. Okay? Okay? So this is clear. So once this is clear, we can start solving problems. So what we did do till now, we saw why triangles are more important, and we listed down few of the properties of triangles. What are they? There are some small properties of triangles. Then we saw why right angle triangles are special, and we saw a few properties of right angle triangles. Then we took a right angle triangle and we just fixed one angle. If we fix an angle, we will get what its adjacent side is and what its opposite side is. Hypotenuse will always remain the same, and we defined some 6 ratios according to that, and then we took some special angle, we constructed some special, and we also saw that this ratio doesn't depend on the size of the triangle. The size of the triangle can be anything, but these ratios remain constant. And then we took a few triangles which are special for constructing 30 degree, 45 degree and 90 degree, and we used we just used the definitions of these ratios and found out all those values. Now suppose I ask what is the value of cot 45 degree? You can tell it, right? You can see what tan 45 is. Cot is the reciprocal of tan, so it's the reciprocal of tan 45, so it's always 1. You get it, right? So whenever you want any ratio of this column, so while solving the problem, see what its reciprocal is and see there and you get it, okay? So shall we start? I mean, if it's clear till now, we can continue, okay? So shall I rub these? Sin of angle is? Yeah, can someone answer it?
Yeah. Possible if you
We
have
can use a log book.
No.
If you're given the other two sides, you can, like, if you're given two sides, you can do it.
Sir, somewhere near 37 degrees or... The other side is...
So, did you understand his doubt? If someone says you, okay, now if I tell you, suppose sin theta is some root 3 by 2, what is the value of theta? See there,
60.
60, right? Because what fits here? 60. Okay. So now suppose if someone says sin theta is some 3, what would be the value?
It's not possible.
It's not possible. Why?
Sir, because it varies between 0 and 1. The curve, sine curve.
Yeah. So if you see the sine ratio, it is opposite by hypotenuse, right? We know that in any right angle triangle, hypotenuse is the largest. Opposite can only be less than hypotenuse, right? So that ratio is always less than 1. You understand? And if you take cos, that is adjacent by hypotenuse, even that should also be less than 1. But if you take tan, opposite and adjacent can be anything, because one can be long, one can be short, and it can be anything. So that can be anything, but sine and cos should always be less than 1. Okay? So now we just defined some ratios and we just did this. And where can we really use this? So the thing is, trigonometry has many applications in like geometry, calculus, astronomy and many other things. Let's see one such application which is called as heights and distances. So heights and distances is something like this. Suppose you have a situation where you cannot physically measure the height or the distance. In that case, we use trigonometry to find out that. Okay. So before we start the problems, let's see some basic definitions here. Okay. I mean, it's required. So first one, horizontal. What's a horizontal? It's a line parallel to the ground. Okay, so that is always horizontal, or we call the base line or something. So for any point, from any point I can always draw a horizontal, right? From any point I can see the floor and I can draw a line which is parallel to the floor. Okay, fine. So this is called as horizontal. Next we define what is called as line of sight. Okay. So suppose there is an observer here. He sees an object somewhere. Consider the imaginary line which joins the observer's eye and the object. Suppose I am here and I am seeing the water bottle there. There is an imaginary line which joins my eye and the water bottle, right? So that is called as line of sight. It is the line in which I am seeing. Okay. So given an observer and an object, we can always assume that there is this line. Okay. And if we notice from the observer we can have a horizontal, right? There is some angle forming here. So this is very intuitionistic. If you look above, the angle goes up. If you look below, the angle comes down, right? So if you are standing on a tower and seeing something which is on the ground, you will be looking down. So in that case, the line of sight would be like this, right? But if you are standing and looking at an aeroplane or a bird flying, it will be above. If the observer is looking above, it is called as angle of elevation because it's up. Okay, and the same way, so that would be angle of.
If the observer is looking straight at the object, what will be the angle?
It will be 0 degrees. It will be 0 degrees, right? So if he is seeing above, it will be called as angle of elevation. If he is seeing below, it will be called as angle of depression because he is seeing down. So from now on, if I at any point of time say that the angle of elevation is 30 degree, it means he is seeing above and the angle forming with the horizontal and the line of sight is 30 degree. And if I say angle of depression is some 65.3 degree, it means he is seeing below and the angle between the line of sight and the angle of and the line of sight is 65 point something, whatever I told. Okay, so all these four things are clear now. One is horizontal or the baseline which is parallel to the ground. Line of sight is an imaginary line that joins the observer's eye and the object, and angle of elevation is where the observer is seeing above the horizontal and the angle between the line of sight and the horizontal is called angle of elevation, and if he is seeing below, it's called angle of depression. Okay. So now suppose I can measure this angle. I mean, if I am seeing some object, I can always lift. Suppose I am not allowed to lift my eye, I should lift my head and see it, right? Yeah. So I will be making some angle with respect to this horizontal. Suppose there is a way to measure the angle between my original position and how much I have lifted. Suppose I know this angle, say let's call it theta. Okay. Suppose I know this angle, can I find the height of this or the distance between this? So
Provided you use the hypotenuse.
right. So suppose I have a little information about this system. If you can see, we already have a right angle triangle, right? So suppose we have some information about this environment, then we can use the properties of trigonometry to find out whatever we want. Okay. So this is the main idea. We collect some information about the current environment or where the problem is arising, and we try to model it in terms of right angle triangles, so many right angle triangles, so that we can get some information out of it, and we can, using that information and all the things that we have defined, we try to get the value that we want. Suppose we are interested in calculating the height of this or the distance, then we can use this properties of trigonometry to find out these values. Okay. So yeah, again you might ask, okay, that is a real world application, but why should you even try to find the height of something? Can't it be there? So yeah, maybe it is used in a war where you try to bomb someone. In that case, all these matters, right? You need to know the exact distance, otherwise the bomb misses. Okay. So now let's start with some problem. So those who have already seen heights and distances, Okay, fine, good for me. Okay, so let's do it slowly because few of us saw trigonometry for the first time, right? So let's do everything step by step. Okay. Suppose you got the answer, fine, but don't shout the answer. Let's solve it on the board slowly. Okay. You are free to solve it on your own. You can just start solving once you get the question. But those who haven't, just see the board, and after 2 questions, you will be ready to solve it on your own. Okay. Okay. So it's 10:15. Yeah. So we can take a break for some time.
We don't want it.
It's okay. You can take a break.
We don't want it.
So one thing is, whenever a teacher or lecturer, even your college, next after you go, whenever teacher is ready to give a break, just take it, okay? So let's come back at 10:25 and start the problems, okay? Fine. Or should we wait? Yeah.
How will we find out the trigonometric ratio for 90 degrees?
Okay, so that's a nice question. So those who are seeing it for the first time, just forget it, or maybe you can also see. Okay, so now I want a right angle triangle with 2 right angles. How can I get it? I can get it this way. Okay, it's not, this is for just the intuition, it's not defined in this way, but let's see it how we can define it. Okay, so I want a 90, this is the 90 degree that we already have for hypotenuse. We want to fix an angle which is 90 degree, and for that we need to find a ratio. Let's construct that right angle here. Now we have this parallel to this, right? It never meets. So now if we take, this is always the hypotenuse, right? Because this is the standard 90 degree that we always want. So the hypotenuse is fixed, this one. So now for this angle, what is the adjacent opposite? This one, right? Assume that it meets somewhere. Okay? This assume that it meets somewhere. Okay? Suppose it meets somewhere. Wherever it meets, these 2 values will be equal, right? So opposite by hypotenuse would be 1. Okay? Fine. So sin 90 is 1. What about cos 90? Cos 90 is 0 because suppose you want those 2 to meet. Once you have some distance, they become parallel line. They have to go till infinity to meet, right? So if they have to meet, in the beginning itself they should have met, right? Only then they would have met. So what you do, you try to decrease this distance. At what distance will they join? When this distance becomes 0, right? So what is the adjacent of this? 0. So 0 by anything is?
Undefined.
0 by anything. 0 by anything is 0. So cos 90 is 0. Okay? Yeah, I mean, this is not the way it is defined, but just to have an intuition of how it can be done, we can use this.
Tan will be infinite. Tan will be infinite.
Yeah, tan because
Yeah,
sin by cos it's infinity, right? And don't tell anyone that sin of 90 and cos of 90 is defined this way, because it's not defined this way. This is just for our understanding. Okay?
So then how it is different?
So they use this allied angles and all. So maybe you will study it in 11th or 12th. Okay. So there is this sin of 90 plus theta is cos theta and such things. So once you know that, you can use that to define when put theta is 0 degree, then sin of 90 plus theta becomes sin of 90 degree. So you will get that. So yeah. Anyways, you will know that later. So now let's go to the problems in heights and distance. I'll read out the whole problem. You need not copy the whole problem. You just copy down what are the things that are required for the problem. Okay. So there is a lighthouse. You know lighthouse in the middle of the sea. It's there for to help the ships. Okay. So suppose there is a lighthouse and there are two ships which are on the opposite sides. Say one is on the north of the lighthouse and one is to the south of the lighthouse. They are exactly opposite. So a person is standing here. He sees this at an angle of depression of some 30 degree. So one thing is very important to note, angle of depression is always with respect to the horizontal. It's not with respect to the vertical. Okay. So there is this horizontal and this angle is 30 degree. He is seeing it with respect to the ship at 30 degree. And when he sees this ship, it is some 45 degree. Okay. We need to find the distance between these two ships. So why is it important? There are these things like
Colliding.
Yeah, one thing is colliding. The other thing is if they want to communicate, they use radios, right? So radios have a definite range. It cannot cross beyond that range. So before they want to communicate with them, they want to make sure that they are within the range of the radio so that they can communicate. What they can do is this person can ask this person and even this person can ask this person whether those two are within the range or not. So this person, he knows how much height that tower is because he is there. So he'll know all the properties of those. So that's why he is there. And he can measure this angle and he can measure this angle. And there is an instrument called theodolite which is used to measure the angle. It's very simple. It will be circle. Here it will be 0 degree and here 0 to 90 and 0 to 90. It increases this way, it increases this way, it increases this way to 90 and it increases this way to 90. So it's just a eyepiece now. Suppose you want to see something here, you just turn the eyepiece. So now if you have an angle, this will be the angle. That's all. So if you want to see something down, this is the eyepiece. Turn the eyepiece so that you can exactly see what it is. So once you have that, this will be the angle. So this is called as theodolite. It's not a very complex instrument. It's as simple as that. Okay. So now this angle is always measured with respect to the horizontal. So that you should remember always. Whenever someone says the angle of depression is 45 degree or something, it's always with respect to the horizontal. Okay. So now our aim is to find the distance between these two. Once we know this, suppose let's say this is 100 meters. Okay, he knows that. So given that the height of the tower is 100 meters, what will be the distance between the ships? Okay. Now let's convert it into a proper geometric figure. Okay. So how does this look? There is one side of length 100 and we know that this is right angle. So if this is 30, I can directly write this to be 60, right? So this is clear, right? Because this is 30, so this has to be 60. Right. So this was 45 given. So therefore this has to be 45, right? Okay. So let's name this. So now given,
If we get it in roots, can we just put it in decimal form?
no, just keep it in roots itself, it's enough. So using these things, we need to find BC. So if we take ABC, it's not a right angle triangle. We can't tell anything about that. So let's forget that. But there are two right angle triangles here, right? So suppose using this triangle, if I am able to find BD, and using this triangle, if I am able to find DC, BC will be the sum of those two, right? Okay. So now let's take in triangle ABD. So in triangle ABD, what all we know, let's first see. We know this angle. So this is always the hypotenuse, but we don't know that hypotenuse value. But for this angle, we know the adjacent value, right? Because adjacent is 100 degree, it is given, the tower. So we need to find such a ratio where only opposite and adjacent are involved, so that we can substitute this to be x, and using this we can get that. Which is the ratio that involves adjacent and opposite? Tan, right? So let's consider tan 60. So what is tan 60? Opposite by, see there, what is tan of any angle? Opposite by adjacent. So in this triangle, what will it be? Opposite is BD, adjacent is AD. So let's write down BD by AD. We don't know what BD is. Let's keep it as BD itself. But tan 60 we know from the table. What is tan 60? Root 3, right? So root 3 is equal to BD by 100. So BD is equal to 100 root 3. Let's keep it as it is, okay? Now let's take this triangle, okay? So in that triangle, in triangle ADC, again we know adjacent and we need to find opposite. Again we need some ratio which involves adjacent and opposite, which is tan again, because here also it was just adjacent and opposite. So tan of 45 degree is equal to how much? DC by AD. Because, right. So what is the value of tan 45 from the table? It's 1. What is DC? That we need to find out. DC by 100. So if we solve this, we get DC is equal to 100. So now what will be the value of, not B, BC is 100 plus 100 root 3, right? We can take 100 common, 100 into root 3 plus 1. What will be the value? I mean, this is a length, right?
273.2.
No. We can keep it like this, but it should need it should have a unit, right? It is length. Why is it meter? This was meter. We didn't change the unit anywhere, so this remains meter. So if you just write 100 into root 3 plus 1, it's not an answer at all, because we are asking the length. The length should be something. If this was a centimeter and someone said it was kilometer, there is a huge difference, right? So unit is always important if it has one. Ratios don't have unit because, can you tell me why ratios don't have unit? Right. Okay. Right. So opposite is also a length, right? And adjacent is also a length. So both will have some unit, say meter. Meter or meter gets cancelled. So both of them will have some unit, which is say meter or centimeter. We are taking the ratio, so both of the units get cancelled. So trigonometric ratios won't have any units.
So what if instead of 60 we have like 70?
Yeah. I'll just tell it. So this is meter. So this problem is over. So in real world, it will not be only 60, 30, 90, 45, right? It can be some 35.2732 degrees. So in that case, you have seen log books, right?
Yeah.
So if you open the log book, there are pages for natural sines, natural cosines and natural tangents. So using those values, how will you look into that? There will be tables, and here you look for the whole degree. So it will be from 0 to 90, whatever value you want, you look here, and here it will be 0, 0, 0, 1, etc. So if you want to see 23.59 degrees, go to 23 here, go to 59 here, whatever is the value here is the sine of 23.59 degrees, okay? Fine. So maybe you should get it out. How did they find it out? Right? So we didn't know anything, but still we constructed 30, 45, 60 and we found out the ratios, right? In the same way, given any angle, there is always a way to find out without using log table also. Okay? So that maybe you'll learn it later. Let's not discuss it here. There is this compound angles, and so if you know what is the angle sine of alpha, using that you can find what is the sine of alpha by 2 or sine of 2 alpha. So all those things we can do. So that maybe in the next year or somewhere you will be studying that. So let's not go into that now. Okay. So now once we have 30, we know 30, so we can find alpha by 2. So that is we can find 15 degrees. If we know for 45, we can find 22.5 degree. So once we know alpha and beta, we can find out alpha plus beta. So we can find 15 plus 22.5, and we can get its half, right? So we can go on doing like that and get whatever we want. Okay. So is this problem clear?
Yes.
Was there any doubt or something?
No, sir.
Okay, fine. So let's go to another problem then. I mean, this was very simple. Let's go to a bit complex problem. It's not too complex, but yeah, the number of steps are more, that's all. Okay. So there is a person standing on the ground. He looks at a aeroplane, okay, and he notes down that the angle at which he is lifting his head is, say, 60 degrees. Okay. He waits for some time. Aeroplane won't stand there, right? It will be moving. So he waits for 15 seconds, and aeroplane would have been gone somewhere else. Now he sees the aeroplane. Now the angle has become 30 degrees. You understood the problem, right?
Yeah.
So
So
there is,
assuming that the aeroplane is flying at the same height.
yeah. So let's not assume, let's know for sure. Suppose the aeroplane is going at the same height. Okay. So aeroplane is going at the same height for sure. So once he sees the aeroplane, it's at 60 degrees. He waits for 15 seconds. Aeroplane has gone some distance. Now he sees again. Now it's 30 degree. Okay. Suppose he knows that maybe he is some airport official or someone. So he knows that the speed at which the aeroplane is moving is some 200 meters per second. Okay. So the aeroplane speed is 200 meters per second. We need to find the height at which aeroplane is flying. Okay. So since both the heights are same, we can find it in any way because it's flying in the plane horizontal. Okay. Suppose it's flying in the same height, we need to find the height. Okay. So now let's convert it into a proper geometric figure. So that problem involved angle of depression. This angle, this problem has angle of elevation. Okay. Okay. So it's okay to find DE or BC. Both are same, right? Let's call it H. We need to find out H. Okay. So if you note that we don't know anything in this except the speed. Using
We can find
Yeah.
the distance travels 15.
we know that it was after 15 seconds, right? Okay. So we can know the distance between CD, right? Because we know the speed of the aeroplane and we know that it traveled for 15 seconds. So what is the value of CD? It is the distance traveled of the aeroplane, right?
3000.
So distance traveled would be speed into time. So distance is equal to speed into time. So speed of the aeroplane is 200 into time is 15 seconds. So this is 3000 meters. So that means CD is 3000, right? If CD is 3000, B will also be 3000, right? Because it's a rectangle. Okay? So far clear?
Yes, sir.
Okay. So now we don't know AB. Okay. So let's keep it as X. Okay. Now we need to find H. what all we know is this is x and this is AB. AE is x plus 3000. Okay. So now suppose if we consider this triangle, that is ABC. So let's write it here. In triangle ABC, what happens? So this is also H, right?
Yeah.
So let's consider any ratio which involves H and X for 60 degree. So what is the ratio that involves opposite and adjacent? Tan. What is, so let's consider tan 60. So in this triangle, what will be the value of tan 60? BC by AB, right? So in this triangle, we fix 60 degree. So the opposite of 60 degree is BC and adjacent is AB. So tan 60 will be BC by AB. What is tan 60 from the table? Root 3, right? So root 3 is equal to BC, we assumed it to be H, and AB we assumed to be X, right? So from this what we get? X is equal to H by root 3. Let's call this equation 1 and keep it, okay? So far clear?
Yes, sir.
Okay. Now let's take the other triangle, which is ADE. In triangle ADE. Now what happens? Let's take, again we know this and this. So we need a ratio for 30 degree and which involves opposite and adjacent. So it is tan again. So yeah, and one more thing, just because in all the problems here we use tan doesn't mean all the heights and distance problem involve tan. We need to select such a ratio where we can, where one of them is unknown and one of them is, the other is known. So it's not that we selected tan blindly. We saw what was the ratio that we wanted and then used tan. It turned out that in all the problems we got tan, that's all. It doesn't mean that it should be always tan, okay? So tan 30, for example, even cot we could have used, right? Because even cot involved adjacent and opposite, okay? So tan 30 is what in this? DE by AE. From the table, what is tan? 1 by root 3. So 1 by root 3 is equal to DE is H. AE is X plus 3000, right? X plus 3000, right? Yeah. So from this, what we get? Let's cross multiply. X plus 3000 is equal to H root 3, right? Root 3 goes here, this comes here. So X plus 3000 is equal to H root. From this equation, we can substitute H by root 3 in place of X, right?
So X will be
X is H by root 3. Let's substitute this here. So it becomes H by root 3 plus 3000 is equal to H root 3. Okay? H and H doesn't get cancelled. Let's take the LCM. What is LCM?
root 3.
Root 3 is the LCM. So it becomes H plus 3000 root 3 divided by root 3 is equal to H root 3. Right? So now root 3 goes to the numerator. So root 3 into root 3 becomes 3H. So let's continue it here. So it becomes H plus 3000 root is equal to 3H. H goes there, it becomes 2H. 2 comes below 1500. So 3000 root 3 is equal to 2H. 2 comes here and divides, so H is equal to 1500 into root 3. What is the unit? Why is it meters? So this 3000 was in meters. So everything becomes in meters. Okay? Is it fine? Understood the problem?
Shouldn't we take the person's height
Yeah, so that's a very good question. Why did we neglect this person's height? Okay, so that is because all the things that we are dealing with is 3000 meters. 3000 meters is actually 3 kilometers.
So even 1 meter.
When you consider 3 kilometers long, the person's height would be very negligible, right?
1.5 maybe.
So that comes in things like how much the value is significant. So for example, suppose you consider the distance between the door and the place where you are sitting. So it is completely different from the place where your adjacent person is sitting, right? So it will be some value. But suppose if you are taking the distance between you and the door, then whatever is the distance between you and the door is different from whatever the distance the person adjacent to you is sitting from the door. Suppose you want to find the distance from New Delhi to you, then it's almost same, right? You can neglect the person. Suppose the one sitting beside you says, I have already measured, it's some 10,000 kilometers. You don't go to measure again, you also say it's exactly 10,000 kilometers, right? Why did this happen? Because for that large distance, the distance between you both became very negligible, right? The same way, when we are dealing with such large distance, the height of the person becomes negligible. So, if you go to the website, there are a few exercises in heights and distances. Try to solve them so that, yeah, the same website that you got registered for this. IMS. Yeah, no, some workshop, invitation to science and, right, so you know that. Yeah, and so in that website you will have all our email IDs. So if you have any doubt in anything, you can ask us. If we don't know, we'll let you know who knows that. And yeah, so the basic aim is to get you people start thinking about things. So start asking questions like, why should it be this? I mean, just because you know you are doing that doesn't mean that it should be that way. For example, sum of angles in a right angle in a triangle is 180 degree. But you should ask, why should it be 180? Why not 185 degrees or 200 degrees? So once you prove that, you accept it. So first thing in science is, don't accept anything without proof, okay? Unless it's a theory, okay? Anyways, so once if this is done, let's go to triangles. Once the triangles are over, let's go to circles, okay? So solve the exercises that are there on the website so that you will be more comfortable with such problems, okay? It's not too hard, but just try them and solve them so that you are comfortable with these. So that if you have already seen these problems, you will be more comfortable, and if you are going to see it in the next year or somewhere in your school, you need not read that topic at all. Okay, so after triangles and after right angle triangle, let's go to circles. So, can someone define what a circle is?
A circle is
All the points
equidistant from a point made in a plane.
from the center.
It's a collection of points which are equidistant from a fixed point, okay? So, we started using words like points. We said a collection of points. So, for that first we need to say what is a point. So, what is a point?
Anything that does not have a dimension.
It's not anything, it's something. It's a geometric figure, okay? So, what's the dimension of a plane? 2, right? Because it has height and width or depth, length and breadth, okay. So, what's the dimension of a cube? 3, because it has length, breadth and height. So, what's the number of dimension of a straight line? 1 because it has length. So for a point it has no dimension. So it is a geometric figure with no dimensions. So a line is a geometric figure with one dimension. A plane or a rectangle is a geometric figure with two dimensions. A triangle, two dimension. Even in a triangle we have length and we also have the height, but the height is not exactly equal to this side, but there is a height, right? So this has two dimension, but as soon as we see the figure we cannot make out what it is, that's all. Okay. So any geometric figure that can be drawn on a plane has two dimensions, at most two dimensions, because even a line can be drawn on a plane but it has only one dimension. Yeah, so a point is a geometric figure which has no dimensions or zero dimension. So now once we have defined point, we can tell about collection of points. So a circle is a collection of points which are equidistant from a fixed point. What do we call that fixed point as? Center. So this point is called as center, and what do we call the fixed distance as? Radius. Radius, right. So the fixed distance is called radius and the fixed point is called center. Yeah. So circle is very different. I mean, circles we study separately because circle cannot be formed by many triangles put together, right? We just said any polygon, triangles are important because we said that. But if we take a circle, we cannot divide it into triangles. So we separate out circle and study that differently. And we separate out all other polygons and study only triangles. Okay? So why is it that circle is special from other polygons?
They don't have sides, but are a closed figure.
Okay.
It can be made.
So you all intuitively know that circle is different from other polygons, right? So each one of you may give a different reason for that and all the reasons are correct. Okay. So now let me give one of the reasons. So to give that reason, we need to define something called as a tangent. Everybody knows what a tangent is? Yes. What is a tangent?
It touches the circle at exactly 1 point.
Okay. So a tangent to a circle is a line which touches the circle exactly at 1 point. Okay. So I define a tangent. Any line can be a tangent given that it is touching the circle exactly at 1 point. Okay. Any line which touches the circle at exactly 1 point.
So no other polygons have tangents.
It's not true.
Like it touch the corner of a polygon.
Yeah, so given any, so the difference between circle and any polygon is as follows. Given any point on this tangent, I can always draw a tangent, right?
Yeah.
I can always draw, let's prove that later, how we can always draw that. But given any circle, we can always draw a tangent. But given any polygon, if someone asks me to draw a tangent at the vertex, I can draw. But if someone asks me to draw a tangent here, I can never draw it, right? So that's how circle is different from other polygon. For a circle, on any point, we can draw a tangent. But for a polygon, we cannot draw it at any point. Yeah, so we can draw it only at some points, not all points. So that is the difference between circle and other polygons in terms of tangents. Okay. So now circle, if you go, we have this circumference, area and such other things. Let's not go into that. Let's study the relationship between circles and tangents. Okay. Only this thing let's see in this discussion.
I have a doubt, sir. Is tangent defined as a line segment or line?
Tangent is a line, it's not a line segment. Okay. So what's the diameter?
Which connects two opposite points in a circle, it's a
Line segment
diameter.
that connects
Okay.
any chord which passes through the center. Passing through any
Okay, so it's any chord which passes through the center. So for that we need to define what is a chord. What is a chord? A chord is a line segment
that connects
which has two endpoints on the circumference of the circle. On the circumference on the circle is same as on the circle. So I'll say a chord is a line. Maybe you should write it down. A chord is a line, or sorry, it's not a line segment. A line, it's a line segment. A chord is a line segment which has its endpoints on the circle. Okay. A diameter is a chord which passes through the center. So the length of the diameter will always be twice the radius. It's the longest chord, so it's not so. The length of the tangent, sorry, not the tangent. The length of the diameter is twice the radius. Length of the diameter is twice the radius, right? Okay. So is this fine till now?
I have doubt. Are tangents and secants somewhat related to trigonometry?
They are, but you'll know it later. I mean, we define that and we have a tan which is actually the full form of tangent there, but here this is a tangent and there is, as we look at it, there is no relation, but actually there is a relation which gives the slope of the circle at that point, and maybe we can look at it later. When you start reading calculus, you'll know what exactly that tangent means.
So then what about the secant?
Yeah, even secant also. Once you know the tangent, you'll know what is secant and all. Yeah, so coming to that, we can define a secant to this. Suppose we have a line segment. Suppose we have a line segment which has its endpoints on the chord, on the circle, we call it a chord, right? Suppose we extend this line segment to become a line.
Secant.
It is a secant. So what is a secant? Secant is a line
Passing through the circle.
which passes through at least 2 points on the circle. So secant is a line which passes or intersects, whatever you can call. A secant is a line which intersects the circle at 2 points. Or if a line intersects a circle at 1 point, it's called tangent. If a line intersects a circle at 2 points, it's called secant. If it is a line segment, it's a chord. If it is a line, it's a secant. And if the circle, if the line doesn't do anything to the circle, it's just outside, it's just a line. There is no relation between them. Okay. It's neither a tangent nor a secant. Okay. So is this clear? So till now, let's prove some theorems. So yeah. So the first theorem that we prove is, I'll write a clear picture so that, yeah. This angle is 90 degree, right? So that's our first theorem. The radius and the tangent, it's not just that. I mean, I can also draw the radius here, right? This line is not perpendicular. It is at the point of intersection, at the point of contact. At the point of contact are perpendicular to each other, right? So let's prove this theorem. So anybody knows the proof? Okay, let's prove it. So I mean, this is very intuitive, but let's prove it. Okay, so proof by contradiction. So suppose this is not true. Suppose this statement is not true. Suppose this statement is not true, then what happens? Then there is another perpendicular to the tangent from the center. So you know what this means? Suppose I drew this line. Suppose this is not 90 degree, then I can always draw another line which is 90 degree, right? I can from a given point I can always draw perpendicular to any line. Suppose this line was not perpendicular, then there is some other line which is perpendicular, right? You understood what this means? Suppose this is not true, then this line is not perpendicular. If this line is not perpendicular, there is some other line which is perpendicular. Let's call that line CB. So let this be the tangent, let's call it L. Let CA be the radius which is exactly joining this. So suppose this is not true, then let CB be perpendicular to L. You understood this? Suppose not, then CA is not perpendicular. If CA is not perpendicular, then there is some other line which is perpendicular. Let's call that line CB.
CB is greater than
Yeah.
because it's more than
Right. So you got the contradiction. Let's just tell it. So we know that CA's length is radius, right? R. But if you look at CB's length, it is R plus something, right? So one thing we know is angle CBA is 90 degree, right? Because we know that it is perpendicular. We said that CB is perpendicular. If C is perpendicular, then CBA is 90 degree.
So AC should be the longest.
Yeah. So if CBA is 90 degree, length of
AC should be greater than
now.
The hypotenuse is CA.
greater than CB.
Yeah, so you already know, let's write it formally. CB is radius plus something, right? Because this tangent is touching at only one point. If I draw perpendicular to any other point, it has to pass through the circle first and then touch the tangent. So it should be radius plus something. It means CB is greater than CA, right? So CB is greater than CA. In this triangle, we knew one property. What is that? If one side is the greater than the other, the angles opposite to that will be greater, right? We just wrote down that property. So what does this mean? Therefore, in triangle ABC, what happens? Angle opposite to CB is what? CA, right?
His hypotenuse should be long.
So angle A is greater than angle B, right? Because angle opposite to CA is B, angle opposite to AB is CB is A.
It's greater than angle.
No.
See, we proved that CB is greater than CA, right? If CB is greater than CA, angle opposite to CB is greater than angle opposite to CA. What is the angle opposite to CB? It's CA. What is the angle opposite to CA? It's B, right? So because of this, A should be greater than B. But we know that B is already 90 degree. Therefore, A is greater than 90 degree, right? So it's a contradiction because it is only one triangle. It has two angles which are greater than 90 degree. So those two sum itself becomes greater than 90. Third angle cannot exist. So this triangle cannot exist at all. So if this triangle cannot exist, then our assumption is wrong. Therefore this theorem has to be true. Okay? You understood the proof?
Yes, sir.
suppose this didn't happen, then there is another perpendicular. Let's draw that. Let's consider this triangle. In this triangle, the new perpendicular that we draw has to be greater than the original line. Therefore, this side is greater than this. Once we have this side is greater than this, the angles opposite to them are greater. Angle opposite to this is greater than this. Therefore, we get that. Therefore, we get a triangle where the sum of two angles itself is greater than 180 degree. Therefore, such a triangle cannot exist at all. Therefore, our assumption is true. Our assumption is false. Therefore, the theorem is true. Okay, so now let's prove another theorem. Theorem 2. Suppose a line intersects circle at least one point. No. If this doesn't tell you anything, and angle between tangent and angle between the line and radius at the point of contact is equal to 90 degree, then the line should be a tangent. Okay, it's quite a long statement. Understand that statement. It's the converse of the first theorem, but we need to prove that. It's just because it's the converse, it doesn't mean it's true, right? Because there are so many converse that are not true, but the theorem is true. Can you give an example for that?
So like all quadrilaterals are polygons, but not all polygons
Right.
are quadrilaterals.
So all quadrilaterals are polygon. So that is, converse will be all polygons are quadrilaterals. That is not true, but the first theorem was true, right? Okay. So now let's prove this. So let's understand this first. Suppose there is a line which intersects at least at one point. It can be 1 or 2 basically, because it cannot be more than 2 for sure, right? Any line can have at most 2. Suppose it intersects at least at one point, that is, it's not too far, it's at least at 1, it's exactly at 1 or 2. And if at any one point it is making 90 degree with the radius, then it has to be a tangent. There is no way it can be a secant. Okay, the proof is very simple. It is also by contradiction. Suppose not. Then what does that mean? Then line should be secant, right? Because then it should be a tangent. If it is not a tangent, if this theorem is not true, then it should be a secant, right? So there is a circle, there is a secant, but at this point it is making 90 degree. This is what the theorem is telling, right? It is intersecting at least at one point. There are 2 points, and the angle between the radius and the tangent is 90 degree. But since we assume that the theorem is not true, it becomes a secant now. Let's call this CA. So it is intersecting it at another point, right? Let's join that.
That will be 90 degrees.
That's not possible.
If you see this, these angles are equal, these sides are equal, right? Because it's the radius. If this becomes an isosceles triangle, right? So if this is 90, this will also be 90, right? That is not possible. Therefore, we get a triangle where sum of 2 angles itself is 180 degree. So it cannot be possible, right? So
So they coincide.
we get a contradiction, and Therefore, it has to be a tangent. It cannot be a secant. If it is a secant, then we get a triangle where sum of two angles itself becomes 180. That is not possible. I will not write the details. You can write it.
Yes. Yes, sir.
I will give you 30 seconds time. Write it fast. Okay. Okay, so let's hurry up. Let's finish fast so that we can have snacks fast. So now, suppose there is a circle, and someone asks me to draw a tangent at this point. So now it's enough if I take this radius and draw a line which is perpendicular to this radius, because we have proved that if we draw it to be perpendicular, then it's a tangent. That is what theorem 2 said, right? So once we have proved this theorem, now it is enough if we construct a perpendicular to this. So before this, we didn't know how to do this. I mean, just someone said do this if you get a tangent, you should have asked why. But once we prove this theorem, now you know why it's enough to have a perpendicular there. Because once we have a perpendicular, it cannot be a secant for sure. It has to be a tangent. So we can do this in many ways. I'll tell you just one way. By angle construction, we get this 60, 60, and then bisect this, and that is one way. I'll tell you one other way. So you know how to, given a line, you know how to get a perpendicular bisector, right? You take more than half, you cut and you join. So have you ever wondered why it should give a perpendicular bisector? Why not something else?
Because
So because
Okay, so go back to your home and just think why it should be like this, and I'm sure you will get an answer.
So like the ratio of this line and that line will
Sir,
be
that's
same.
because
So
they
the
are
ratio
Because
of
they are equidistant.
Okay, so I just consider it to be a whole circle instead of an arc, and this also a whole circle instead of an arc. You will get the answer. Just go back and think about it. You will get the answer. Yeah, I mean, there are many different reasons you are getting that. Each one of you might come out with a different reason for why it should be a perpendicular bisector. All the reasons will be correct unless you don't have some nonsense reasons. Okay. So now I want to construct a tangent. This is R. What I do is I extend this line and I take a compass and I cut exactly R here. Now I draw a perpendicular bisector for this. I can do that, right? Because I can take half, cut this and join this. Once I know this, I know for sure it is making 90 degrees, and it is also passing through this point because that is the midpoint. So this becomes our tangent. So this is one way to do it. Okay? Got it?
Yes, sir.
Very simple construction.
Sir, we need to construct a tangent first. That's a
Yeah, that's our aim. So we did that. Okay. So now the second aim of this is, suppose there is a circle and someone tells me there is a point outside and I should draw a tangent from that point to this circle. How can I do that? One thing you should remember, you should note is, from any point outside we can always draw a tangent. From inside we cannot, because it has to cut, and if we extend this way it will cut another side. So from outside we can draw tangent. So but before proving this, we need to prove another, before seeing how we can do that, we need to prove another theorem. Theorem, I think you know the proof, that is, if we have a circle, I will not write the statement, and if you have a diameter, the angle subtended is always 90 degrees. You know why?
Degree measure.
Okay, so let's forget all those and let's see one short proof of this. Okay, so I'll be writing the proof here itself. Maybe you can go back and check it. Suppose let's say this is x degrees. consider this triangle OAC. This line is equal to this line, right, because radius. So this angle will also be x. Suppose this is y, this angle will also be y because OC is equal to BC. Now consider the whole triangle.
2x plus 2y is 180.
Whole triangle side should be equal to 180. So x plus y is C, A is x, B is y. This should be 180. It means 2x plus 2y is 180. If I take 2 common, 2 plus x is equal to 180. Therefore, x plus y is 90 degrees. So this angle will always be 90 degrees. Okay. So once we know this, we can construct that. How can we construct that? Suppose I have a circle and someone gives me a point outside, and someone asks me to find out a tangent from this point. I have the center. Suppose I somehow find out the midpoint of this. I draw a circle. It will pass through this point, right?
Yes, sir.
It will pass through this point also, right? So now if I join, I know this point, right? So if I join this line and this line, what will be this? In this bigger triangle, it is diameter subtending, right? So this is 90 degree. Now if you see this smaller triangle, this is the radius and this is some line which is making 90 degree. So by theorem 2, this is a tangent. By theorem 3, this is 90 degree. By theorem 2, this is a tangent. Got it? So how are we doing this? Suppose we have a circle. The first step is to find the, so our aim is, given a circle, we need, and some other point which is outside the circle, we need to find a tangent from that point. So how do we do that? Step 1, consider the line joining center and the point. Find out the midpoint. How can you find out the midpoint? By perpendicular bisector. Just cut 2 lines and this is the midpoint. Once you get the midpoint, draw a circle. It will pass through the both the points because it is a midpoint. Now you get one point here. Draw this. This is our required tangent. And if you notice, there will be another point, right?
Yeah.
So you can also join this. There is nobody stopping you to draw this. So what does this mean? From any point outside, you can have 2 tangents. Okay? If we are given with only one tangent, I mean, if we are given with a point on the circle, we can draw only one tangent. But if you are given with a point outside, we can draw 2 tangents. Okay? Is this fine? Yeah, so, yeah, it's already time, so let's stop here. Yeah, so we can go for snacks and come back by 11:30. You have 10 minutes. Go soon.